Hi, welcome back. I want to take a look today at two words that I bet you've heard your teacher or your friends say, or you've read about. They're all the way through the geometry book. One of those is postulates and one of those is theorems. So let's see what's the difference in those, how they are alike and how they are different. They are alike in that they are both laws. Postulates are laws, truths. Theorems are laws, they're truths. They're both true all the time. They're different, though, in that whenever you have a postulate, it's like wonderful because it has just been given to us as a law, and we can understand it and accept it and use it. A theorem, however, has also been given to us, but it has been given to us to prove. We can't just take a theorem and run with it. We have to make sure that we understand why a theorem is true, and we won't prove every single theorem for sure because we don't have time, but theorems are laws that must be proven, and postulates are laws that we do not have to prove. So first of all, we're going to start with some postulates about lines and planes, which we've already talked about. So let's take a look first of all at, and I'm not going to name these postulates because different geometry books out there name them different things. Sometimes different teachers name them different things. So I think it would be confusing for me to name them something that your teacher or your book might name them something different. But you can be sure they're in there. The first one I want to look at has to do with a line, and this is what it says. It says 2 points determine a line. Now, I will make everything as simple for you as I possibly can, and I cannot leave out anything that's really important. So I'm saying a line, 2 points determine a line. Now when I say a line, it really means exactly one line. But you understand that for me because I'm telling you, if it says a line, it means 2 points. Here's a point and here's a point. It means any 2 points determine one and only one line. Now you say, well, what does determine mean in this case and the way it's used here? Well, it means if you have 2 points anywhere, any 2 points, you can draw exactly one and only one line through those 2 points. So let's do. So there's our line. And you know you name it with any 2 points, so we might as well use those 2 points. And we'll name this one capital B and this one capital D, because we could name them anything, and then that line would be called line BD. Okay? Now it doesn't mean that those are the only 2 points on the line, because you know that the line is full of points. It is actually made of thousands and millions and infinitely number of points. It just says if you only have 2 that are given to you, then anytime you have 2 points anywhere, then you can draw a line between them because every 2 points determine a line. So let's look at what would happen if we had 3 points. If we had 3 points, we could have 3 points that would make a line like this. Those 3 points would turn into a line if we connected them. Or I could have 3 points that would not determine one and only one line. They would not determine a line. So that is why we can't say 3 points determine a line, or certainly not 4. But any 2 points in the entire world will determine a line. Any 3 points might, but then 3 points this way would not. So that leads us to another definition I want you to learn. These points that are in a straight line are called collinear points. You see the word line in there. Co collinear points. And collinear points are points that lie on the same line. Collinear, they lie on the same line. 3 points that do not lie on the same line are called non-collinear. Points. Because you cannot put a line, one single line, straight line, that all of those points would be on. So that's a definition of collinear points, non-collinear points, and the postulate that says any 2 points determine a line. Okay, now let's take a look at plane a little bit. Let's change over to a different color, and let's look at what would determine a plane. What would determine a plane? Now it says a plane, it means one and only one plane. So if we had 1 point, just 1 point, then it could lie on lots of planes, because it could lie on this plane that it's on right here, and I could have another plane that goes like this, that point is on. I could have another plane that's kind of slanted a little bit, but it's still a flat surface that goes through that point. So 1 point is not enough to make one special, exactly one and only one plane. So 1 point's not enough. So if we have 2 points, we're like, well, maybe that's enough. So we get 2 points. So we get 2 points, we're like, well, would that determine one and only one plane? Well, here's one plane they're on, but you know, here's another plane they're on too. If I take a plane and pass it through them like that, so that's at least 2 planes that those 2 points determine. So I can't say that 2 points would determine a plane. If I had 3 points, let's look back over here. If I have these 3 collinear points, 3 points in a straight line, they are in the flat plane of the board for sure. But here's another plane that this plane right here represented by this piece of paper will slice right through those 3 points and contain all of them. So these 3 points, and then there's another one. There are a lot of planes at different angles that I can't draw, but I can understand would slice through there and create another flat surface that had those 3 points on there. But look at this one. So 3 collinear points cannot make a plane. Not just one special plane. But here, in this situation, I've got 3 non-collinear points. They're not in a straight line, okay? Then they are on this flat surface right here that we call this board, and there is no other way that I can place this paper which is representing a plane for us, so that it would contain all 3 of those points. There's just no way. There's no way that I can make this paper work where all of these points will be on it. So there's just no way, except being flat down. So to determine a plane, I need 3 non-collinear points determine a plane. 3 non-collinear points determine a plane. I'm going to have to go back here and put another L in, because collinear has 2 L's in it, so I'm really glad that I caught that before we moved on. Non-collinear, collinear has 2 L's in it. Doesn't seem like it would, but it does. So hopefully you understand the difference in those first 2 postulates, and they're not any big deal. They're obvious to most people once you kind of think through them. The next thing I want to look at is not a postulate, it is a definition. In geometry we have theorems and postulates and definitions. So let's go to definition right now. Let's look back at our line. 2 points determine a line. And let's now look at something that we're going to call a line segment. think if you had to guess at that, you would already know, because you know that segment means part. So a line segment says, hey, if you've got a really long line, or if you've got a line which is unlimited in length, then you can pick any 2 points on there, pick the B and the D, and if you just chop your line off right there, that is a line segment. So if I did that and I had B here, point B, and point D there, then that would be the way that I would draw a line segment. So a line segment does have a measurable length. I can measure it. It has a beginning point, has an ending point, so we call those end points. And if I want to know how to write the notation for a line segment BD, then I would do it like this. I would write B, capital D, line segment over the top. Or I could go the other way, point D to point B, and it wouldn't make any difference. So notice the difference in notation. Capital letters, either way, doesn't matter, both endpoints. Capital letters with a little, kind of a little picture of line segment on top of that. So a line segment is truly just part of a line, and that is a definition that rather than a postulate or a theorem. Let's look at this similar thing, and it's called a ray. And this is another definition that I want you to understand. I'm not having you write out precise definitions. All of those are in any geometry book that you pick up, whichever one you happen to be using for your class. They all have definitions, and sometimes they're worded slightly differently. I'm trying to help you understand the meaning of this so that any definition you can relate to it. So let's look at a ray. You can think of the ray of the sun, and you think of the sun, and you've got these rays coming out to the side all around it, and we drew those when we were little, etc. So what is a ray? It's part of a line again. It has one end point, not two. So here is a ray. It has one end point, and then on the other end, it goes into infinity. It keeps going. So if I want to know how to write this, how to name it, I name it by the end point always. And then there's just millions and infinitely number of little points there. So pick one and name it whatever you want to, a capital letter because it's a point. Now if I want to name this as a ray, then I would write AP, and I would put the little ray symbol on top of it. So that, geometry is full of shortcuts and notations, and they're really clear if you just get them straight from the beginning. This says ray AP. I cannot name that one ray PA because I have to start with the end point first. So it has to start with whatever is on the end. It has to start with ray A going in that direction. Okay? Now you might have a ray that is coming like so. And let's say that that's capital S, and that point we will name it capital T. And if we want to name that ray, we start with the end point, which is S, capital, and then we go to T. So that is ray ST. The S has to come first, and then the little ray symbol on the top. It doesn't matter which direction this might point, the ray symbol always points to the right over the letters. So we will understand when we see this is ray starting at point S, continuing through T forever, starting at point A, continuing through P forever. This we cannot measure a ray. We can't say, well, this ray was 2 inches long, because it goes forever. It only stops on one end, it doesn't stop on the other end. So that is a little bit of beginning about a couple of the beginning postulates and understanding about lines and line segments and rays, which all go together, and a little bit of understanding about collinear and non-collinear. We'll review these as we go. Great job today, great beginning, and I'll see you tomorrow.